Hey guys, and welcome back to Pixel Soccer Global Tournament Making Of, Part 4. First I want to say sorry, in Part 3 I said it was Part 4. I made a mistake there because I had already recorded 4 parts, but the first part was not really part of the making of. It was more like an introduction, and therefore I numbered them from 0 onwards, and I just made the mistake to forget about that. But now we're in part 4, and today we'll have a look at another important part of every game. It is controller input. And under Windows there is a lot of ways. There are a lot of ways to capture controller input. There is direct input, and there's the new X input API by Microsoft for their Xbox controllers. But since all about this game is supposed to have this old school flair about it, we'll do a very old school way of capturing controller input, and this is by polling status information for the controllers. And since we have, if you remember, we have a central game loop which runs, or which restarts every few milliseconds, we can poll information about our controllers in the loop, and it's no problem. And I made a little test project for it, and this time I'm not gonna program on the fly, since this is a more complex theme and I had to try out some stuff because I never used it before. I didn't want to annoy you by me figuring out why it is not running or why it's not working as it is supposed to work. So I finished the code and tested everything out, and it's working pretty well. And what I'm going to do now is show you the project, what it does, and later on I'll show you the code. So let's start by looking at the project. So as you see, we have this nice little window here with this list box and this capture button. And as you see in the list box, all of the possible controllers are listed. Of course, I didn't list the mouse because hopefully nobody's insane enough to play a soccer or football game with his mouse. So I thought about supporting the keyboard and supporting joysticks or joypads. Nowadays nobody plays with a joystick anymore. And so as you see, we have our keyboard input, and we have 2 joysticks. I have connected to my PC. I have a USB Microsoft Xbox 360 controller, and I have a Logitech, I think it's called a dual action controller. It looks exactly like a PlayStation 2 controller. It's a bit older, but it's still a very good controller, and it has the same amount of buttons and the same layout for the most part as an Xbox controller. So it's working out pretty well. So those are the 3 things that are connected to my PC right now. And what I did in this test project is programmed the input, and then I programmed this little window which captures the input by creating a loop similar to our game loop we already used for the back buffering. And when I press a button up here, there'll be a label that shows you which buttons are pressed. So let's start with the easiest thing. Let's start with the keyboard. If I press capture, then you see that the capture has started. And now I'm going to press some buttons on my keyboard. So for example, pressing the left arrow key on the keyboard, as you can see down here, left is shown in the label. If I release it, it's gone. And of course I can press the typical buttons we'll need for our game, like shoot and pass and change player and run, or speed up running to be exact. And if I press the escape key, this is the pause signal we will use later for the game, and now it will stop the capture and it will say capture has ended. Let's restart it. Of course, you would think that you could press more than one button or one key at a time. So this also works out seamlessly. I can press left and up, for example, and while I'm pressing left and up, I can press shoot. So my player will be running left to left and up diagonally, and he will shoot. So if I release all the buttons, it's released. Okay, let's press escape again. The same goes for the joysticks. The joystick, I'm using the very old joystick API from Windows Multimedia. It's still working like a charm. There's no use in looking for anything else. I'll try it out on Windows 8, but I'm pretty sure it will work there too. So this joystick here with the ID 0 is the Microsoft 360 joystick, and if I capture it, I can take the joypad. Of course you can't see it, but I hope you believe me. And I can press the buttons, you know, shoot, run, shoot and run, and I can use the analog stick to control it left, left, down, down, right, down, etc. And I can shoot, of course, as well, and run. So it works like a charm. And if I press the start button, the capture ends. The same thing goes for the dual action controller. Start the capture, and I can use the analog stick, but I can also use the digital input for X and epsilon, X and Y axis. Sorry, I'm always saying epsilon for Y, but in German it's actually epsilon, and therefore I mess up with that a lot of times. But back to this. The capture started, and now I can use the Logitech joypad, left down, down, right up, press some buttons. All 4 buttons on the front of the controller are pressed now. I release them, and then I press the start button and the capture ends. So, works like a charm, and the reaction time is also so slow. So slow, yes, so fast that it won't be a problem for a very fast and frantic game to use this. Okay, so now that you've seen what it does, let's dig into the code. So what did I do? As you can see in this project, I will make the window a bit bigger so you can see everything. So we have 4 classes. We'll work with classes for the first time now in this project, but classes are pretty cool and are pretty useful. And even though Visual Basic 6 is not object-oriented, it has some features that let you program your functions and tools in an object-oriented manner, or in a nearly object-oriented manner. Since all these classes are compatible to the COM standard, they support interfaces. Interfaces are very central for COM, but what they don't support is inheritance. A real object-oriented language like Java or Ruby or something, they support inheritance, which is on one hand very important. On the other hand, it's just plain and simple easier, and you do not need as much copied code as you would need in Visual Basic, since it only it supports interfaces, and therefore you have to copy code that you would in other languages just place in the class from which your other classes inherit. So what Visual Basic supports is called polymorphism, because we have a interface class iInputDevice, which has stumps of properties and functions that are needed for every input device, whether it is a keyboard, whether it is a controller, or whether it's anything else. And let's look at this. What I did is I made some properties like device name. Of course, later on you want to see which input you are using. A refresh sub. This is called in our game loop to refresh the status of the buttons and keys of the controller, or for polling, if you will, polling information about it. And then we have the buttons we will be querying. It's left, right, up, down, shoot, pass, run, change player, and pause the game. 4 buttons. I think 4 buttons are enough for a good soccer game, and I think that in certain situations certain buttons will have another meaning, but we'll get to that whether once we have like actual gameplay to look at. But right now, in my abstract thoughts, in my mind, those are the buttons or keys we'll be using in the game. So every controller must implement this interface, and there's a collection class input devices, which is instantiated in the game later on, and it houses all of the possible input devices. So if this class is initialized, you see that here. What does the class do? Well, it adds a keyboard input device, because normally every PC you play on would have a keyboard. Apparently, I hope so at least. And I just add this as a device, and then the magic happens with the Windows joystick API. Device joystick is of class input device joystick, like here, which is basically an implementation of this interface plus some additional voodoo for this certain controller type. The same goes for the device keyboard class. It implements the interface plus it does what is needed for a keyboard to recognize the state of the keys, which are pressed, which are not pressed. We'll look at them in detail later. For now, for the joysticks, there is a simple function, API function, joy get num devices, like this, and it returns the maximum number. This is important. Therefore, when you use Microsoft APIs, it's always important to read exactly what the MSDN says about them, because sometimes it's very weird stuff happening in there. In this case, this gets the maximum number of joysticks supported by the device driver. And in my case, it is 16. Could be less, could be more, I don't know. This is not really explained in too much detail in the MSDN. So, and the indices or the IDs of the joypads and joysticks connected start at 0, and they go to num devices -1. So in my case, from 0 to 15. And what I'm doing here is I'm creating instances of the input device joystick class, and I give them a ID. And in the joystick class, if the ID is attached or set in this case, then the device capabilities of the joystick with this ID are queried, and if you need 5 buttons to play, 4 buttons to shoot, pass, change player and run, and 1 button to pause, or this is what I'm thinking right now. It could change later, But if a joystick doesn't have enough buttons, I mustn't add it to the input device collection because it's not very useful for the game. So, if the joystick capabilities are queried and afterwards it doesn't have enough buttons, well, it's not added, otherwise it's added. So now if an instance of this class is created, we get a list of all input devices, and if we do refresh all, it's just a convenience function. We can just, or convenience method if you will, and you can just it will just call refresh for every input device in the collection. Then if you create collection classes, having trouble talking today, in Visual Basic, if you create your own collection classes, you can actually make them real classes that that you can use in a for each loop. So if I have such an instance of this input devices class, I can actually do for each device in devices, and it will loop through. If you create this function, the new enumeration, with an IUnknown interface, this is the central thing in COM. IUnknown is supported by almost anything that is a COM class. And what I'm doing is just taking my internal collection I use to actually store my devices, and set it to the new enum function of this collection class. And the last thing you have to do is go to attributes, procedure attributes, and for one, change the visibility to so it won't be visible, and the procedure ID to -4. If you do this, you can use it in a for each loop and it will just work out of the box. You don't have to do anything else. Then there's an item function. This is standard in a collection class to get an item with a certain index, and I'm just using the item function of the collection, the internal collection. And for convenience, you can also go to attributes and set it to the default. I think it's default in English, probably. So you do not have to write devices.item and then in brackets the index, but you can then write devices brackets index. So you can leave out, just like with the collection class, where you don't have, if you put it like this, if you type this, it's basically the same as item index. They're equivalent, and it's a convenience method as well. Then we have count, and at terminate we just destroy the collection, and all of the devices will also get destroyed and terminated. So now for the actual device classes, let's start with the keyboard. And the only API we need to query keyboard states of keys is get async keyboard state or key state. It will basically just look if a key is pressed at the moment the API is called. It's not interested in anything, you know, like if the key is handled by any application, or if like it is a, I don't know, a hotkey for something, or if your window has the focus, it just doesn't care. It's just getting the state of the key on a very low level, and this is cool for us in this case, because what we do, we have a variable for the device name, which we of course set to keyboard at initialization. I'm sorry. And when the instance of the class is initialized, we get the current button state or key state by just calling the refresh sub. We'll look at it. then, since we're polling it, we have to save the states of the buttons. So I made some Boolean variables with, I think, names that speak for themselves, like left, right, up, down, etc., etc. And if the refresh is called, what the class does is get the keyboard state of all of the buttons. If getAsync key state returns 0, it means the button is not pressed. So implicitly it means if it does not return 0, the button is pressed. So therefore, since Visual Basic, like many languages do, just interprets a non-zero return value as true and 0 as false, we can just put one of our Boolean variables and the key state of the key we decided to use for this function. For the left function, of course, we use the left key or the left arrow key on your keyboard. And so if this is not 0, this will be true. If this is 0, this will be false. And luckily, all of the virtual key codes are there as Visual Basic constants. So you can do VB key is set x epsilon x y. I'm always saying epsilon. I hate this absolutely, because since I studied bioinformatics, I had to use y so often for chromosomes, for example, and I just don't get it why I always say epsilon, but it's just human nature, I mean, or German nature in my case. So forgive me that. It's of course y. I don't know. Good. Let's get back here. So we ask all the states for true and false, and then for every key we use, we have a property that returns the value of the internal Boolean variable. So now, how does the interface stuff work? Of course, to be in the input devices collection, our keyboard device must implement iInput device. This is done by writing implements iInput device. Who would have thought that? And if you do selected, you can select all of the properties and methods that you defined in your interface, like the refresh, the pause, device name, etc. And how Visual Basic does this is by just writing, if you select one of them, like left or change, it doesn't matter, like the name of the interface, and then the name of the property or function or method or whatever. And all you have to do is, like, let's say, for example, return for the properties, just return the value of your actual left value. And after you implemented all of those, and they're all like written in bold, this is enough so that the interface implementation will work. So this was the easiest part. I mean, we just had to ask for the key states whenever the refresh is called, and it is of course called at the beginning of the loop. We'll look at this later. And now for the joystick class, which is a bit more interesting. Let's see. Let's start. We need some API declarations. We need some of those constants up here. You can read them. Then we need user-defined types of type joy caps, which are the capability of the joystick. And we need joy info x, which is a type that is used to query the state of the buttons and the position of the analog or digital controller or stick. So, and there of course the two APIs that come with that, the joy get device caps and joy get pos x. And what else do we need? Of course we need an ID. We don't need this. We don't need this with the keyboard, but we need it with the joysticks, because there can be as much as apparently up to 16, at least on my machine. Of course, it has a device name too, and it has a maximum number of buttons, or the actual number of buttons that are used. Those we don't need anymore. I will delete them. They were from testing, so they're gone. And we have the same Boolean variables, left, right, up, down, etc. we had with the keyboard class. And here we have some additional variables, min-x, max-x, min-epsilon, max-epsilon. I'll tell you shortly what they mean. When this class is initialized, we do not know its exact name or anything, because we can not know this before we set a certain ID here, as you see in the input devices class. When the number of joysticks are queried, as I said, a new instance is created, and then the ID is set. And then, when the ID is set, the class queries the device capabilities, and if this works out, it is added to the collection. So we have, of course, our normal property get, which will return the ID that was set, and we have a friend property let, a setter, if you will, that lets the input devices class set the ID. And if the ID is set, the capabilities are queried into this joycap structure, and the MSDN says if this works out, the return value is joy error no error, which is just a name for 0. It's just basically if anything but 0 is returned, there was something is fishy, or something didn't work out when running this API function. So if the error is 0, we can query the device name from the SZP name, and I add, since as you saw earlier, apparently with the same driver, always the same name is returned. Like in my case, it says Microsoft joystick driver and something like that, and therefore I just added this ID so you can know which one you're looking at, even though you only see the name like in the list box. And the maximum number of buttons that it supports is caps num buttons. And now we get to this extra variables. In the cap structure, there are 2 values for every axis. There is a x max and a x min value, and those are the maximum values that pressing very strongly to one of the sides or up and down, that the value can become. In my case, it is from 0 to like 65,000, so to it's basically in the integer range, but I'm not sure this will be the case with all of the controllers, since the calibration could be different or anything. So first I actually used the max and min values to determine whether the user presses to the left side, the right side, up and down. The same goes, of course, for epsilon, which is up and down. But I noticed that, especially with the analog stick of the 360 controller, this didn't work out too well. So I thought, okay, maybe it's not, I mean, especially with the analog stick, if you're like wheeling it and stuff, it is not supposed to be exactly in the same spot all the time if you press into one of the directions. So therefore, I said if at least 1/3 of the maximum difference of the direction is reached, this would mean that it was pressed to the left. And if 2/3 at least are reached, this would mean that the user pressed to the right. The same goes for up and down, 33%, 66% about. And as it turned out, testing, it works for all of my controllers, it works exactly like it should, so I'll leave it like that. And of course, after everything is initialized, we'll do refresh for the first time. And refresh, let's look at that. Refresh uses the joy-get-pause-x function, and you get the joy-info-x structure, and you have to set the size, so the API knows what kind of structure is there as a parameter. There may potentially be different structures, or if the structure has the wrong length, it may just fail without doing anything. I don't know for sure. And then you can set flags, and the flags tell the joy-get-pause-x API which of the fields of the structure it should fill. And in our case, we need which buttons are pressed. This is joy return buttons, and the x and epsilon axis, and this is joy return x or joy return epsilon. I'm saying epsilon again. I'm so sorry for doing it. Just maybe it's easier for us if you actually acknowledge that y in Germany means ypsilon and therefore translates to epsilon in English. I don't know. Just accept it. I think you can read what I'm talking about. It's not. I'm not having a good day actually. Despite programming this, I'm pretty through today. I don't know. Okay, be it as it may. So we ask for the information, and then we set like we did with the key states in the keyboard class. We now set our Boolean variables, and as I said, if the x-pause is smaller than 1/3 of the maximal position the axis can reach for this controller, I set it to true. Same thing with right, top, down, and here the buttons, it's just a bit mask. You know, you start button 1 is actually 1 decimal, which means 2 by the power of 0, and it's just, this is 2 power 1, 2 power 3, 2 power 4, etc. And at least for my controllers, it turned out that for both of them, Logitech and Microsoft, the start button is button number 7. So, and the number of buttons is actually higher. It is 10. So I'm just going to say 2 power of maximum number of buttons minus 3, and this will be the pause button. It could change for some controllers. Maybe later on we'll make the usage of which buttons you use like selectable by the user, you know, do your own configuration stuff, but that's far away as far as I can tell now. But well, this is all the magic that is needed to capture the output of the controllers. And if we look back here at the form, as you can see here, if we press the command button, there is a loop, and if I remove all this from the loop, you see that it's basically like our main game loop. It has a sleep, in this case with 15 milliseconds, and it has the do events, and it has the do loop. And inside, let's get this back, the device that is selected from the list box here is refreshed in every loop. If the pause button, which is at the moment is escape for the keyboard, and the select or the start button on the gamepad is pressed, the loop ends, and the capture ends, and the window is enabled again. In any other case, we have this label label buttons, which will show what buttons are pressed, and there's a string label caption which will buffer the button names. I did this by just creating an array of all the possible buttons: left, right, up, down, shoot, pass, run, change. Pause we don't need because pause is queried here, and then I go there, and for each button I use the call by name function, which is very cool, and it's one of the really cool features of Visual Basic. It's kind of it's similar to Java reflection, since you can just give it an object and a string that represents like the name of a method or of a property you want to call, and the type. It can either be a, let's see if it shows, yeah, it can either be a let, a get, a let, a method, or a set. This is, well, these are all the types the Visual Basic classes support. Set is like let for objects, but otherwise they are totally identical. And by calling the getter of one of the buttons, it will return true or false whether the button is pressed or not. And I will just say if true, button so-so. It will just be added at the end of label caption, and a space is added at the end just as a separator. And after all of the buttons have been checked, the label is set to the string buffer, and yeah, the pressed buttons are shown. Well, so this is all we need. Let's look at it again. Let's look at the 360 gamepad again. So we start the capture, and now I have the analog stick, and I poke it around. As you see, I'm making a circle, and you see left up, right, right down. So I think it was a pretty good idea to say that I used the maximum area of values that one of the axes can have, and say if we press to 1/3 in one direction, it's okay, and 1/3 in the other direction is okay, and therefore it's pretty neat. It works like a charm, and as I said before, I can press all the buttons, and left, right, up, down, etc., etc. It works seamlessly, and this is what we need. And as you see, I can actually, it's also flickering, means that I'm just tapping the button, tapping the button, tapping the button, and it's working pretty well. And this is cool stuff, and it will be easy to use this in the game. And of course, we'll have to work on it later on. As I said, if the user will be allowed to enter his own configuration, of course, then we'll have to ask for all the buttons on the keyboard and for all the buttons on the controller, which will be a task that we have to deal with later. But at the moment it's working pretty well, and I will implement it into our game project, and we'll see the next time. I'll do some easy stuff where I will use the controller to move a rectangle. You remember we did a rectangle last time, drew a rectangle onto the the window form, and next time we'll use our gamepad to steer said rectangle around the window. That's all for now. I hope you enjoyed this. There is a small cut in the middle since my phone rang, but I just continued at the same spot, and I hope you don't mind. And if you like this, and if you find it interesting, if you can use this for one of your own little pet projects, if you're a beginner or anything, I don't mind. If you just give me a thumbs up, and even more, I'd be happy if you join in for part 5, which will come next time, and will be more fun more fun with rectangles apparently. And but we're heading into the right direction. We have the input. Now we'll have a look at how our graphics engine, if you can call it, that we'll see will work. And yeah, I hope you'll join again, and that's all for now. Bye.